discussion centers on the theoretical possibility of using an arc fault circuit interrupter, or AFCI, as an alternative to a ground fault protection of equipment, or GFPE device for de-icing equipment. Firstly, it's crucial to understand the fundamental purpose of each device. GFPEs are specifically designed and tested for de-icing equipment, acknowledging that this type of equipment may exhibit unique electrical characteristics compared to standard loads. AFCIs, on the other hand, are designed for general-purpose applications. The question arises whether AFCIs possess the same level of sensitivity and reliability in detecting ground faults within de-icing equipment as GFPEs. Secondly, code compliance is paramount. Article 426 of the National Electrical Code, or NEC, mandates the use of GFPE for de-icing equipment. Substituting an AFCI for a GFPE would technically constitute a code violation, unless a specific code amendment or local exception permits it. The NEC prioritizes safety and has specific requirements for a reason. Thirdly, reliability and safety are key considerations. The primary function of GFPEs is to protect personnel from electrical shocks and potential electrocution. While AFCIs offer protection against arc faults, they may not be as effective as GFPEs in detecting and interrupting ground faults in de-icing equipment. This difference in effectiveness can present a significant safety hazard. The cost of each device is also a factor. AFCIs are typically less expensive than GFPEs. However, cost savings should not outweigh the potential risks and reduce safety associated with using an AFCI in place of a GFPE. The decision must be made responsibly, prioritizing safety over budgetary concerns. Now let's delve deeper into the current sensitivity of these devices. Both AFCIs and GFPEs are designed to detect and respond to ground fault currents. However, the specific thresholds and response times may differ. A GFPE typically trips at around 30 mA of fault current. It is important to verify that an AFCI intended for use in place of a GFPE has a similar or more sensitive tripping threshold for ground faults. Considering the electrical characteristics of de-icing equipment, which can include heating elements and other specialized components, the potential for ground faults exists. These faults can be caused by insulation breakdown, water ingress, or other factors. A GFPE is designed to quickly interrupt the circuit in the event of a ground fault, minimizing the risk of electrical shock. In contrast, an AFCI is primarily designed to detect and interrupt arc faults, which are characterized by erratic and potentially damaging electrical arcs. Arc faults can be caused by loose connections, damaged wiring, or other factors. While AFCIs can also detect ground faults, their primary focus is on arc fault detection. It's essential to understand this distinction when evaluating the suitability of an AFCI as a GFPE alternative. Let's consider the practical implications of using an AFCI in a de-icing application. Imagine a scenario where a heating element in a de-icing system develops a ground fault. If the system is protected by a GFPE, the GFPE will quickly trip, cutting off power to the system and preventing electrical shock. However, if the system is protected by an AFCI, the AFCI may not trip as quickly, or it may not trip at all, depending on the nature of the ground fault. This delay or failure to trip can increase the risk of electrical shock. Now, let's discuss the NEC requirements in more detail. Article 426 specifically addresses the requirements for de-icing and snow melting equipment. This article outlines the requirements for GFPE as well as other safety measures. It's important to carefully review Article 426 and any applicable local codes before making any decisions about the type of protection to use. The NEC is a comprehensive set of standards designed to ensure electrical safety. Compliance with the NEC is essential for protecting people and property from electrical hazards. It is also important to consult with a qualified electrical engineer or inspector before making any changes to an electrical system. These professionals can provide expert guidance and ensure that the system meets all applicable codes and standards. They can also help to assess the specific risks associated with a particular application and recommend the appropriate protection measures. Let's delve deeper into the cost considerations. While AFCIs may be less expensive than GFPEs, the the cost saving should not be the primary factor in the decision-making process. Safety should always be the top priority. The cost of a potential electrical shock or fire far outweighs the cost of a GFPE. It's also important to consider the long-term costs of using an AFCI in place of a GFPE. If an AFCI fails to properly protect the system, it could result in damage to the equipment, injuries to personnel, or even a lawsuit. These costs can quickly add up, negating any initial cost savings. Now, let's examine the reliability of AFCIs and GFPEs. Both types of devices are designed to be reliable, but they are not foolproof. AFCIs and GFPEs can fail due to various factors such as manufacturing defects, environmental conditions, or improper installation. It's important to regularly test AFCIs and GFPEs to ensure that they are functioning properly. Testing can be performed using a simple test tool that simulates a ground fault or arc fault. If a device fails to trip during a test, it should be replaced immediately. Regular testing can help to identify potential problems before they lead to a serious electrical hazard. Furthermore, consider the potential for nuisance tripping. Nuisance tripping occurs when a device trips unnecessarily, interrupting power to the circuit. Nuisance tripping can be caused by various factors such as electrical noise, voltage fluctuations, or faulty equipment. While nuisance tripping can be inconvenient, it's generally better to have a device trip unnecessarily than to have it fail to trip during a genuine fault. It's also important to properly size AFCIs and GFPEs for the specific application. Using an undersized device can lead to nuisance tripping, while using an oversized device can reduce its sensitivity to faults. Consult the manufacturer's specifications and the NEC for guidance on proper sizing. In conclusion, while using an AFCI as an alternative to GFPE for de-icing equipment may seem theoretically possible, it's important to carefully consider the code requirements, safety implications, and reliability concerns. The NEC specifically requires GFPEs for de-icing equipment, and AFCIs may not provide the same level of protection against ground faults. Safety should always be the top priority, and cost savings should not be the primary factor in the decision-making process. Consult with a qualified electrical engineer or inspector before making any changes to an electrical system. Remember that electrical safety is paramount, and it's always better to err on the side of caution. The potential consequences of an electrical shock or fire are simply too great to take unnecessary risks. The purpose of electrical codes and standards is to protect people and property from electrical hazards. By following these codes and standards, we can create a safer electrical environment for everyone.